Hello, everyone. My name is Dr. Murad Bouash. I am a performance or principal performance engineer at Verizon Media. Today, I'm going to be, I will have the pleasure to give you this presentation to intelligent performance engineering. I would like to thank Intel for this invitation. It's always good to give a presentation and also share our feedback on the V2 Summit. So thank you very much for folks for the invitation. So the intelligent performance engineering is not going to be kind of the actual performance engineering is kind of less intelligent or less smart. It's just we are going to talk about the features that makes this field more intelligent, or maybe how we can make it more automated and smarter than before with all the artificial intelligence features or technology that actually is the trend right now. So just to give you a kind of a little bit of an overview for my career, it's mostly performance career. I come from the academia, so I did my PhD in France in computer architecture. A few postdocs, one in France and one in Illinois, United States, and also one in Waterloo, Canada. So I got a lot of performance kind of research and academia, where maybe you see 80% software and only 20% hardware for maybe the resource, and also you know, in the university lab, you don't have a lot of access to maybe data centers or compute resources, for instance, the servers or different components in the server. So we are really limited. And it's completely different when I mean performance or practicing performance in the industry, especially at Yahoo with 35 data centers, both and Verizon, where you see maybe 50%, 50%. I would say 55% hardware and 45% software. Why this slide? Because I think the performance career is more about interaction between software and hardware. You interact a lot with the developers and the programmers, and also at the same time you need to have this knowledge about the hardware, because they are waiting for you to give them a recommendation, the best configuration for the best execution of their application or service, or whatever you want to call it. So performance is a field that everything is connected. It's not only about CPU or network, or power or IO, memory or accelerators. I'm talking here about GPUs, FPGAs, ASIC, anything. So it's all about this interaction, this connectivity, or this connection between every component, the efficiency, speed of execution of the instruction, where you talk a lot about microarchitecture, more trying to get the best performance in terms of load and store, branch prediction, also looking at the counters, always hardware counters that are giving us the best information about the health of our server or about our device, where if we are talking about CPU or anything else, and trying to minimize the waste, trying to minimize the execution of this application of software, spending it in a CPU execution, and trying to take advantage of all the resources, like using all the CPU cores, all the CPU threads for the best process parallelism, and this give you the best performance, which means the best user experience. Because at the end, it's about how fast, if we are talking about mobile application, how we can give this opportunity to our users to stick with the application, or the mobile application, and use it every day. Same thing with the website, same thing with any application service. At Verizon Media, we're talking about like everything, internal customers, which are the teams that we are interacting with them. But at the end, it's going to be giving the best service or giving the best application to the end users. As Sri said in the last summit, and I like it, like the definition of performance engineering is this deep understanding of application performance, characteristic, domain expertise in software and hardware bottlenecks, and the idea is how we can deliver the best performance goals in terms of hardware, in terms of software as well. So I think if it's time to give this or show this to, I would say, students that they're finishing that or graduating, more about what's performance and what's the difference between performance engineering and also software engineering. At Verizon, this is how we try to tackle issues and performance issues. Is first determine if it's a hardware or software issue, because these two are completely different. I would say software issues are more complicated because they are more dynamic than hardware. People, they think it's just replacing when it comes to hardware, but it's more complicated to reproduce the issue and try different solutions. When you have different frameworks, when you have issue with memory, CPU, so you need always to dig deeper and understand what's the issue in terms of hardware. Same thing with disk and network. For software issue, we do a lot of code analysis. We need to talk to the developers to communicate most of the time, and then do the code profiling using some simple tools like part of the Linux package, or maybe even if you are using Windows, then you need to go with a small test tools just to check what's the issue globally, or general exploration. But after this, understanding better and better what's the problem is coming from, it's either connection between or interaction between software or hardware, but also you can also use more, I would say, more advanced tools like vTune, for example, Perf, and other tools. When we find the solution, it's going to be the validation in production host, and then roll out to all affected production hosts, because it's going to be mostly repeat operation at this point. Performance engineering, it's about profiling, benchmarking, monitoring, and tuning. I would say it's not going to be kind of in this order. Sometimes you need to do profiling, where you try to analyze what's the function, what's the operation is causing this issue for better user experience, and try to save costs. Sometimes it's connected to the revenue directly, and believe me, when we do this, it's going to save a lot of money for the company when it's affecting the revenues directly through the latency or low throughput. Benchmarking is more about evaluate the system, evaluate the function, and then monitoring is more observing the behavior, I would say analyzing the data as well if we are collecting some data, and it's kind of part of the troubleshooting operation. Tuning is actually the last, maybe the last operation or the last step, where you find the solution, you find you find the bottleneck, and then you try to even get better performance, knowing the performance requirements, and then trying to find some alternative in terms of function, talk to the developers and see how we can increase the throughput or even reduce more and more the latency. For this, when you have a system, starting with the hardware, device drivers, Ethernet, a virtual memory, system call interface, operating system, to the top of the application where you are in the user mode, every step or every stage has its own or bench of tools that can help you analyzing, monitoring, profiling, and also benchmarking. These are the tools that usually we use. Part of them maybe like the packages of Linux, because this is what essentially we are using as operating system. But also we can use external tools like, for example, Intel vTune for different stages here, understanding more about the hardware, collecting more data to understand what's the problem. Also at the application level, to profile, collect the data, and understand what are the functions that spending most of the time in the CPU, or what's the memory efficiency. All these analyses are part of Intel vTune. But other packages, other tools that are very helpful in different level of our system. For the performance analysis, usually we have specific methodology. We are not jumping on the advanced level or advanced tools, because there's sometimes we have overhead. Sometimes it's a little bit complicated to collect the data, especially when we are in production level. The idea is to go through basic steps to intermediate step until the advanced step. For the basic steps, we usually use simple tools to understand what's exactly happening on the system, on the software, and also the hardware. We have our Intel system monitoring as basic part of the basic level. After this, we jump to intermediate as in the next step for process monitoring, for debugging, package analyzer, and then if we need to go with advanced level, we can use gprof or profile, Intel V2 and perf on other profilers for deep analysis. Mostly, I would like to give my experience for VTune, and and also it's one of the performance profilers that we use a lot in Verizon Media for basic profiling, because the idea about VTune is not only a good profiler, but you can go through different level on the system. If you want to do a basic profiling just to understand what are the hotspots, you can use VTune general exploration, like very quick profiling, just to see where is the problem, or help someone like a programmer or a developer understanding what are the hotspots, and then talk to the developer and see if he is familiar with this function, and if really he thinks that it's causing the issue or the bottleneck on the system or on the entire application. Then it's very helpful in terms of speed and how fast it is to take decision or share some information that can help understanding better the system and finding the solution. Threading analysis for lots and weights, usually for concurrency. Even you can go to the microarchitectural level for analysis if we'd like to see what's the cache, branch prediction, all this. If the system is healthy in terms of microarchitecture, the vectorization, you can use a different tool, Intel Advisor, to get the flops estimation. Even with the trace analyzer and collector, you can check the scalability and the overload of your system. For memory efficiency, it's very helpful to use VTune, and it's the specific memory analysis for that to check the memory efficiency and other things. The good thing also is the virtual machines and containers. VTune is very helpful, and these features are very helpful when you are working on containerized systems or virtualized systems as well. Just to give a traditional, and this is very connected, it's connected very much to the traditional performance engineering in general. This is what we do when we use Intel V2 amplifier to collect the data, or benchmark, if you want to call it like that. We need to create our benchmark first as first step. It should be repeatable, and then representative, easy to run, and also you can measure with high precision, either from the system application and processor or CPU going down to the hardware level. And then the second step is about collecting the data. When we collect the data, we need to make sure that the data are very representative. It's not going to be collecting data for a specific time where maybe we have high throughput or low throughput. We need to make sure that it's exactly how the application is running in production. We need to collect this data too. At the end, we can get some information that's going to be very helpful. After this, we need to analyze the data, try to identify the performance problems, talk a lot with the developers, more communication. I would say communication here is going to be the key, understanding exactly what happened in the system, and then fix the problem on the code or system. If the problem is solved or fixed, then we can say that we are, if we fix the problem, are we meeting the performance requirements, which is going to be about tuning. If yes, then we are going to get some optimized code at the end. If not, then we are going to repeat this operation, collecting the data, analyzing, and then fixing the problem again. And this is going to be through, as I said, system, application, and processor. The features, in addition, on VTune is this centric or central server where you can collect without limit different servers at the same time, or different other spaces where you have your application running. You have this platform profiler for longer data collection, which is very helpful, and actually we use it especially when we have a new technology in CPU. We try to see what's the health of our system or server for a long time. finding hardware configuration issues, and identifying the poorly tuned like Horizon Media application. For cloud containers and Linux, it's very, very helpful, especially for when we use Java applications and easier profiling of remote Linux systems. I would say always there is new things that can help understanding better the performance, and actually Vitun is helping, I would say, the performance engineers a lot to find the bottlenecks. It's all about time. We need to do it. Sometimes we have emergency. We don't have a lot of time to identify the issues, and I think Vitun is very helpful in this way, especially when you do a remote Linux analysis. It can be with a server, it can be with a tablet, a mobile that has an Android device, and it's really good, especially when the interface, when you collect the data and you start analyzing the data, because actually you spend most of the time analyzing the data. Now we go from this traditional way to a new approach, a new trend. Everyone is talking about this artificial intelligence, machine learning, and deep learning trend. And of course, at our company, at Verizon Media, we have a lot of application. Some of them they are in progress for development. Some of them they are ready, and we are actually running some of them in production. So we need understanding better the performance too. We are done with the model, either for training or inference. Now we need to think about how we can use performance engineering to understand better the artificial intelligence applications. For different, for a different type of application, can be image processing, speech processing, natural language processing, recommender systems, and also everything which is connected to, deep learning. And essentially, the two main operations are trainings and inference. The good thing I like about this package or portfolio about Intel, that you have this the full package, the full solutions from the hardware, software, and also the community. For the hardware, you have all these CPUs, especially for inference, very helpful. Even also with the FPGA and all the new solutions that are coming for GPUs, especially for training, and also the software that is covering as the next step. For example, the experience with OpenVINO was amazing. All these deep learning platforms that they are optimized through the Intel solution, or Intel CPUs, are very, very helpful. TensorFlow optimized by, or Python optimized Python with Intel, with Intel features. And this community where you can connect with people, find solution, discuss specific topics that are very connected to what we're trying to do. Intel AI Dev Cloud, which is very good platform where you can start your test before maybe moving or migrating to your own system or data center or cloud. Very, very helpful and very, it's going to be, as they said, Intel says speed up the development with open artificial intelligence software. So as I said, the new applications trend, we are between training and inference and workflow, of course, most of our work right now is about inference and optimization for inference with Intel. For training is more about compute intense or intensive computing resources using GPUs. But these two operations are the main new operations, or the future operation when it comes to optimization to performance. I would say it's going to be a specific performance engineering with these two operation inference, especially when it comes to the edge. You have small space, less connectivity, compared to the training where you need a lot of compute, as I said. But you have this in the data center. You are more comfortable in space, and you are more comfortable in power, which is completely opposite on inference. So I would say these two operations are going to show a new trend of performance engineering, of performance optimization in the future. Data. This slide is all about the data. How much we are spending time labeling, loading the data, cleaning the data, because of course we were talking about the concept of the problem of big data, how we can take advantage of this using the artificial intelligence to solve some specific problems, but we are going to spend a lot of time trying to label the data and manipulating the data as well to make them ready. And then we can build after this on top of it the model, and this model is going to solve some problem, and then we are going to use this pre-trained model for inference after that. So I would say mostly performance engineering is also going to help a lot trying to solve some problems in terms of optimization and performance in data manipulation, extraction, labeling, loading, all these things are going to be very, very important if we would like to get a good model and also good pre-trained model for inference after that. One of the examples, these slides actually, how we switched, and I'm going to talk about more about intelligence, this intelligence, and it's the title of my presentation, the intelligent performance engineering. So what's this intelligence? This intelligence, if we are talking about all this data collection, if we're talking about specific project about time series, and we had actually this project in collaboration with Intel for anomaly detection. And the problem is in our large clusters, we have mixed workloads, and the ability to automatically identify the abnormal systems or anomalies, especially when it comes to CPU utilization or memory efficiency. It's a big challenge for a performance engineer. We have this system that's collecting all the data, kind of a database, understanding the performance. And as you can see in all these steps, we need to do performance too. So we need to reduce the metrics, get some specific data frame, and then we are going to build this model, and then understand if it's one means that it's an anomaly or not. Of course, the model is great, and then the training was great. So we were hitting the accuracy for almost 99%, but we can do a lot of optimization in every step. We can do it when we actually migrate the data, reduce the metrics, shape our data frame, and also the performance is going to be very, very helpful for the model, and also for the inference after this. So even I would say a pipeline for building the model for artificial intelligence or machine learning or deep learning, the performance is going to be here. And if we can find tools for profiling, for benchmarking, that exactly what we did with the previous and traditional way is going to be very, very helpful in terms of optimizing better the artificial intelligence, machine learning, and deep learning applications. Yeah, as I said, it was a very good and very helpful project with the Intel for smart anomaly detection. This is how we call it, and I would say it's one of the gates of the new trend of performance engineering for artificial intelligence, machine learning, and deep learning. And the idea is to how we can understand what's anomaly, what's not anomaly for very low usage, let's say for less than 5% across selected metrics, and also for the anomalous behavior like memory leaks, for example. And then it's not only understanding the anomalies, but also understanding your application. And when you understand your application, you understand what are the hardware or what is the hardware that you can allocate, what's the best hardware that you can allocate for this application. Other AI projects and at Verizon Media, and also they are all connected to the performance as well. This is going to be mostly about another team, the Leo team, which is Leo team is working a lot with the performance engineering in terms to again how we can apply this performance engineering or performance optimization within the artificial deep learning application, either for data analytics, computer vision, object detection, specific project face recognition, streaming videos and images. This is also a big project with Intel using VPUs, for example, and also building this platform for alert analytics and monitoring that is going to give us better visibility of different applications that we have, especially the AI application over all the company. Yes, so for this, we have all this package, all this, the API that we are going to use, this toolkit. It's like a core set of tools and the libraries for building and deploying the high performance and data centric application across the different architectures. And actually, Intel One API as an ecosystem, it's kind of delivering this freedom to develop within a unified tool set and deploy application and solution across different, I would say, it's XPUs, either CPU, GPU, FPGA, or other accelerators, with all these libraries that can be very helpful as a second level, which is part of the Intel One API. And then it's very connected to different platforms that we'd like to use, either with TensorFlow or different libraries like NumPy and so on. OpenVINO, we had a lot of experience with that, especially with the Leo team. And also we actually, we are going to use vTune and stand in how we can optimize the inference, especially on the level of the optimizer. Very helpful. I would say this ecosystem is going to accelerate this performance, improve the productivity of any artificial intelligence application, and speed development. It's also about this performance, the new performance engineering using one API. Intel Dev Cloud is really a good solution that can accelerate and help a lot developers to develop their model, and especially when it comes to inference. We just have free access with all packages, all the accelerators already installed in the cloud through Intel Dev Cloud, especially for the edge. And you can actively prototype and experiment with artificial intelligence workload. There are some templates, some exercises that people that can use and understand better how you can use resources in terms of inference. You have CPUs, FPGA, GPUs, VPUs already installed. You just need to develop your own model and then make it functional. Big challenges, of course, and this slide actually is linked to what I was talking about for performance, unique inference need, integration challenge, no one size fits all. All these things they have some connectivity to the performance, especially unique inference needs, low performing, lower accuracy models deployed. Integration also, there's a huge problem of integration that can be very, very helpful using one API. So the challenge is more about deploying the deep learning application and also performance, the speed, time to market, I would say. For the hardware, I would like to talk a little bit about the hardware that Intel is offering for the AI applications. And especially that they are very helpful in terms of performance and the edge. Intel Movidius or the VPU, low power computer vision, all the application connected to computer vision and inference. We had the experience with this. Very helpful hardware that can help developers get more innovation, more ideas that can be developed very quickly using all the solutions that I was talking about, Intel One API and also Intel Dev Cloud, using the Intel Movidius already installed on the system, but also other solutions like Intel FPGA, integrated graphics, all these solutions that it can be on the data center, it can be on the edge, or also the device too, that can be very, very, very helpful. The software, I was talking also about the OpenVINO, very easy to build your own trained model using platform that I already integrated, TensorFlow, Caffe, any other platforms. And you can use also a big database or open model, they call it Zoo, more than 100 open source optimized pre-trained models. And then the next step is about optimization, where you have the model optimizer, you can read, load, and do the inferencing with the intermediate representation. And also here, there's I would say, very smooth connectivity or connection to Intel vTune can help a lot on optimization or profiling the system. And then deployment after this, which is going to be the natural step for inference engine, there's a deployment manager that can help with different XPUs that Intel is offering. This is kind of a conclusion for my presentation. Hopefully you enjoy it. Yeah, what I was talking about is to an intelligent performance engineering, and the performance is going to be, of course, we are not going to ignore the traditional way that we have been doing it, and then what we are doing right now. But also the future is going to be performance of the data collection, how we can help this process, data labeling, all the artificial intelligence, machine learning, and deep learning models, and also for the training and inference operations. So it's going to be specific performance engineering for each step in artificial intelligence and machine learning and deep learning. So I think we are facing a new trend, not only about artificial intelligence, but also using performance engineering for the artificial intelligence. And it's going to be exactly how the software engineering, the life cycle of the software that everyone knows, especially when you are a software engineer. Same thing with performance. We are going to add a new step of a different type of application and how we can optimize these applications. They are completely different than a normal or traditional application. Creating a model is not like creating a normal or traditional application. So performance engineering is going to add new features specifically for this type of applications. So what's next? Next is going to be, I know at the beginning, maybe the intelligent performance engineering is going to be how we can use artificial intelligence for performance engineering. I was talking about more how we can use performance engineering for artificial intelligence. But also there's this topic about using artificial intelligence for performance data analysis and find patterns that can help application performance characteristics, kind of similar to the project of anomaly detection, real-time visualization, especially when it comes to infrastructure, data centers, even for the cloud, using Intel tools for profiling and root cause analysis. So in the two ways, I think the performance engineering is going to help a lot, and I think it's going to be very essential for artificial intelligence, either using performance engineering for artificial intelligence, or using artificial intelligence for better performance engineering or for better performance optimization on the system. Thank you very much. This was my presentation, intelligent performance engineering. Please, if you want to ask questions and if you need help, you can go through my LinkedIn account for people, external people. If not, then you just send me an email at boash@verizonmedia.com. Thanks, and I'm looking forward for your questions, and also looking forward for another Intel summit with a new topic. Thank you.